Pauli magnitude. Now, once you understand the meaning of dot product of two vectors, it is easy to understand that work done by a force is actually the dot product of the force vector and the displacement vector. If you notice here, a force vector F produces a displacement S on this object. F is a vector, S is a vector. Now, what is work done? Work done is the product of the displacement vector and the component of the force in the direction of that displacement. Now, the component of the force in the direction of displacement is F cos phi, where phi is the angle the force makes with the direction of displacement. And therefore, work done is F dot S. What does that mean? It means it is S times the component of F in the direction of S. It is F times S cos phi. That means work done by a force is the dot product of the force vector and the displacement vector. It is the product of the displacement and the component of the force in the direction of displacement. That's what it means. Alright. Work done is a measure of the dot product of the force vector and the displacement vector. In other words, W equal to F dot S. Now here, S is the displacement vector and F is the force vector, and therefore F dot S equal to F times S times cos theta. The magnitude of force vector times the magnitude of the displacement vector times cosine of the angle between the two vectors. And theta can actually be then written as, can you write an expression for theta? We had written that earlier. Theta will be cos inverse of F dot S divided by magnitude of F times magnitude of S. Cos theta equal to F dot S divided by F times S. And therefore theta is cos inverse of that quantity. Let's do a small problem. Find A dot B and the angle between A and B if vector A is 4i plus 6j and vector B is negative 2i plus 3j. Also find the angle between vectors A and B. Well, the first thing to do is to find the dot product of vectors A and B. How do you find the dot product of vectors A and B? Multiply the x components. Now 4 multiplied by negative 2 is negative 8. And multiply the y components. 6 multiplied by 3 is 18. So A dot B is negative 8 plus 18, that is 10. Okay, now tell me, what is the magnitude of this vector A? Vector A is 4i plus 6j. What is the magnitude of that? Well, magnitude of a vector is the length of the vector. 4i plus 6j is this vector, 4i plus 6j, and the magnitude is the length of this. Now, this is 4, this is 6, therefore the magnitude of the vector A will be square root of 4 squared plus 6 squared. Is that right? So vector A is 4i plus 6j. Its magnitude is the length of that vector, which is square root of x squared plus y squared. Alright, so magnitude of A is square root of 4 squared plus 6 squared equal to 7.2 approximately, and magnitude of B is negative 2 squared plus 3 squared, and that is approximately 3.6. Alright, what is the work done? Well, we have already found the work done, is that right? Because work done is a measure of the dot product of the two vectors. But I don't think I wrote it correctly. I should have written one more step there, and like this. Because A dot B equal to 10, work done therefore equal to A dot B equal to 10 joules. Then only that answer will become complete. Work done by the force therefore is A dot B. But apparently we are not asked to find the work done. We are asked to find only A dot B. Well, cos theta equal to A dot B divided by magnitude of A times magnitude of B. And what is that equal to? A dot B is 10, and you know these values. That will be 10 divided by 7.2 times 3.6. That is 0.386. Therefore, theta equal to cos inverse of that value, and that is 67 degrees. Rather simple type of problems. Another problem. A force vector F equal to 5i minus 2j acting at a point produces a displacement given by S equal to 3i minus 4j. Find the work done and the angle between the two vectors. The same problem, the one we did before. So, since the work done is a scalar quantity, the dot product of the vectors is a scalar quantity, and for this reason I told you the dot product is also called the scalar product of two vectors. And you know how to find the dot product. F equal to 5i minus 2j and S equal to 3i minus 4j. What is F dot S equal to? Multiply the x component, multiply the y components, and add them together. So the product of the x component is 5 times 3, 15. And the product of the y components, negative 2 multiplied by negative 4 is 8. Therefore, the work done equal to F dot S equal to 15 plus 8, that is 23 joules. Alright, now we need to find the angle between the two vectors. What do you do for that? Well, first of all, we need to find the magnitudes of these vectors. What is the magnitude of the force vector? It will be square root of 5 squared plus 2 squared. You don't need the negative sign because when you square it, it becomes positive. And that will be square root 29. The magnitude of the displacement vector is S equal to square root of 3 squared plus 4 squared, that is 5. Angle theta is cos theta equal to F dot S divided by magnitude of F times magnitude of S. That would be 23 divided by square root 29 times 5. And that is 0.854. Therefore, theta equal to cos inverse of 0.854. And do that on your own and see what you get. Cos inverse of 0.854 is 31.4 degrees. So the work done we calculated as 23 joules. That is the work done. And the angle between the two vectors is 31.4 degrees. Let's now do another problem. A 3 kilogram block slides